And we are back. Hope you enjoyed the drinks. We have one talk, and then we'll hopefully have dinner. As last time, we ordered pizza, and then the pizza was like an hour late, and that was not fault to our time zone difference. And now also we expected the dinner to arrive at 5, but well, we're calling them right now. But in the meanwhile, we have Andrew from New Relic. We use a lot of New Relic within Sanoma, so we're really happy that these guys want to come over and present some more of the tips and tricks about using it for doing performance analysis on your site. So give a round of applause for Andrew.
Thank you, and good evening, everybody. So why do businesses need to turbocharge website performance? 3 seconds. 1, 2, 3. After that, you've lost your customer. We're in the age of digital transformation, and it's something that we've all been going through for quite a few years now. And for those in the publishing and the news industry, it's perhaps more important than for many other industries, because it's affected the way that these industries do business more than ever, as people are shifting to online in terms of getting their news and finding out what's going on in the world, reading up on the latest gossip. At Davos, at the World Economic Forum, we had some extremely rich people talking about digital transformation. And they were talking about how it's a fundamental shift in how we do business. And it's transforming existing industries. And this is something that I think we're all seeing on a day-to-day basis. It's really changing the way that we can engage with our customers and with our consumers. We're also in the age of customer experience. For anyone that's younger than myself, we've got very different expectations in terms of how we engage with very large brands, how we engage with companies. Nowadays it's online, it's using things like Facebook and Twitter. It's very much more expected to be immediate in the way that we interact with these brands. And you can combine digital transformation with customer experience. They go hand in hand. And this Wall Street Journal quote from 2014 really encapsulates what it's all about. Digital transformation is really about figuring out how you can apply this disruptive technology and how it affects the customer experience, and working out what that means for us and what it means for our businesses. Forbes, just at the end of last year, talked about this year being the year of the millennial customer, and asking if you're ready to deliver that sort of customer experience that they're expecting. And the thing about the millennials is that they expect your company's technology to simply work. So you've really got to make sure that it does. And for anyone that's met my mum, it's not just the millennials that expect these technologies to work. The next generations also expect nowadays that websites and iPads and computers will also just simply work. It's worth bringing this up again. Customers expect your company's technology to simply work. But what do we actually mean by simply work? Well, we need to actually define what working really is. What is working from the point of view of our customers? Sherlock Holmes, the fictional character, wrote that it is a capital mistake to theorize before one has data. So we might all think we know what makes a good experience. We might all think we know what makes things simply work. But unless we're capturing data to help us understand it, then we're making a capital mistake. Gut feel's really no feel for gut feel is no compensation for statistical information that can help us to understand what our customers are expecting. So what might this data look like? The by now probably quite notorious article in the New York Times from the end of last year talked about the cost of mobile ads on 50 different news websites. And what was interesting about it is they talk about how long these pages take to load, but they make no qualitative or quantitative assessment on what actually is a good experience. They simply highlight how long these pages are taking. So we're going to have to look somewhere else for our data to figure out what makes a good experience. And so there's this great website that the URL is just about fitting on the page at the bottom there that gives us some links to some fantastic research that tells us some of the numbers that we can use to measure our customer experiences. 47% of people, almost half of the people visiting a site, will expect it to load in 2 seconds or less. Just over half of them will abandon a page if it takes 3 seconds or more to load. So when you're thinking about the effectiveness of your customer experience, when you're thinking about how sticky your site is, whether you can get people to go from page to page, just bear in mind that if it's taking more than 3 seconds to load, you're likely to be losing your customers. And then a site that has that loads in 3 seconds experiences 22% fewer page views, higher bounce rate, fewer conversions than a site that loads in 1 second. So what we know from this is that if you're going beyond 3 seconds, bad things happen. You start losing advertising revenue, start losing conversions to sales and things like that. So that gives us some nice metrics, some nice data on what actually makes a good customer experience. And that's going to help us to understand when we start to analyze what our experience looks like. Three seconds. That's our key metric. Is your site faster than 3 seconds, or are you losing money? Are you leaving money on the table? Are you affecting your business? Are you hampering your company's digital transformation? If it takes 3 seconds for your PowerPoint to load, then you're doing something wrong as well. So, your customers expect your company's technology to simply work, and now we know that simply work means a page speed of less than 3 seconds. I'd also argue that it should be a reduction in the number of JavaScript errors on that page as well. Because if you've got JavaScript errors, somewhere along the line, something's going to break. So I was a bit cagey about what the number of JavaScript errors should be. I would argue you should be aiming for 0%, 0 errors. Because if you've got errors, then your page, your technology is not simply working. Something somewhere is broken, and you can't predict how that's going to affect your customer experience. So a good customer experience is less than 3 seconds, and this is why we have to turbocharge our websites. Before we do this, it's worth thinking about the evolution of software and what's going on in IT in general. Some other reasons why we should be turbocharging our website that go beyond a good customer experience. If you roll back a few years, we used to build software on servers that we would stick into racks in a data center somewhere. Nowadays we tend to be using, or move forward a little bit further, we started to use things like virtual machines and abstracting away the hardware. Then we started to move to containerization, having discrete units of applications. And as we move towards the brave future ahead of us, we're starting to look at things like Amazon Lambda, where we're not dealing in terms of applications or virtual machines or physical servers, we're talking in terms of units of computation. And as we go down this, or as we go forward in this path in terms of evolution, the focus becomes more and more on what is the performance of your application, because that becomes more and more directly tied to the cost of delivering that application. When it was a number of applications running on one physical server, it was easy to say, well, it's the cost of the server and maybe some power and things like that. When you're talking about a Lambda function running in the cloud, the cost of delivering your experience is how long does that particular function take to run. And suddenly, slow-running functions really hurt the business bottom line. So that's another great reason you should be thinking about how to turbocharge your customer experience and make your sites run as fast as they possibly can. If you want to read more about serverless architecture and what it means, this is a great article that talks about how we've evolved in terms of our approaches to computing, the move to microservices and things like that. And I guess we'll be able to distribute the slides afterwards so you don't have to sort of copy down that link. I'll tweet it as well. Lord Kelvin, who some of you may know from some sort of temperature scale amongst other things, said, "To measure is to know." I'm paraphrasing a little bit here. But you really need to not just be considering the overall performance of your application, you also need to measure all of the things that build up to your customer experience and to constantly iterate and improve the experience that you're delivering. If you're not doing that, you end up with a situation like this. If you're sitting back and just waiting for things to go wrong, suddenly you'll have a server that catches fire somewhere in the room and you'll have to go and put it out and find out what broke and why it broke. You'll have your developers and your operations teams and your database guys all pointing fingers at each other saying it's their fault, it's not my fault. You'll be losing money. Your business will be your business will be offline. You won't be able to take revenue in. And you'll get bad feedback from your customers, and you'll get bad reputations on social media. You don't want those things. What you want to do is evolve to a point of proactive management of your performance so that things don't blow up. You can stop them from going wrong before it happens. Just to really hammer this home, in case you haven't got the message yet, time is money. O'Reilly are writing a book on it, and they're directly talking about the fact that web performance has a very specific business value. So it's really important that we focus on making our sites as fast as they can be. And you want to get to the point, as I said, of being proactive in the way you're dealing with your site performance. The bad old way would be you would wait for an alert to say this disk is full, this server is offline, something's on fire. Then you would go in and find out what was wrong, and if you were really lucky, you would be able to resolve it. You want to be moving towards a sort of state of grace in terms of your infrastructure and the way you're delivering your software, so that you have a very interactive way of exploring the data you're capturing about your site performance. You're investigating things on an ongoing basis to find out where you can squeeze out the last bit of speed in terms of improving the site. And it should be an iterative process. You should be constantly doing this on a daily basis. What can we make run faster today? And if you're doing this properly, then you're also getting incredible value out of your time as developers as well. You're focusing on the things that really matter, the systemic performance issues that are going to affect the way your sites perform. So, that's the end of the slides. I'm going to show you some of the ways in which you can do this. And Angus is going to shoot me, but bear in mind the tool here doesn't really matter. What actually matters is that you do this. You've got to make sure that you're capturing this sort of data and that you're looking at it and using it to improve the way you deliver your sites. So, what we have up on screen here is actually New Relic's application performance monitoring tool. And I'm starting on the application side of things. And what you can see in this chart across the top here is how long it's taking to deliver a transaction from the back end out towards the front end of our application stack. And what you can see here is that actually, for the vast majority of the time, we're spending a pretty constant amount of time in this blue area here, which is the JVM, and slightly lumpy amount of time in this web external thing. And we could drill in here and we could actually say, well, what's actually slowing down in this particular chunk of time? And we can start to explore our data and see where some of these bottlenecks are. And you can see here that actually about, sometimes it's taking up to about 400 milliseconds to deliver a transaction. And if you bear in mind that what we really want to be doing is delivering an entire page to the end user in 3 seconds, if it's taking half a second on the back end just to put the page together and send it out, we're already pretty much falling behind in terms of how quickly we can deliver that page to the end user. So you really want to get this number as low as possible, down to sort of maybe 100, 150 milliseconds. And this is a demo site, which is why it's a little bit slow occasionally. But when you're looking at your data, that's the sort of target you should be looking at, because if it's over sort of half a second to a second, you've got very little chance of getting your end user experience to the levels that your customers will be expecting. Now we can dive into this in lots of different ways and slice and dice the data, but actually I think from the point of view of the end user, the back end is not going to make that much of a difference, although I've just said that you've got to keep it fast. One thing we know from looking at a vast range of different customers is that typically the biggest slowdown is on the front end. 80 to 90% of your performance issues will be there. So if we switch over to the front end now, in fact I'm just going to click on that link, we can jump to that same time slot on the front end, and you'll see that for this particular site, the purple bit at the bottom there is the application backend. Then we've got a chunk of time being spent in the network, but we've got a huge amount of time that's being spent in delivering the page out to the end user in terms of DOM processing and page rendering. So if we want to have the biggest bang for our buck and get our developers to be the most productive they possibly could be, this is probably where I would be starting. This is where things are running slowly, and this is where there's a good opportunity to optimize. So we can take a look at some of the ways in which we could actually do that optimization. So I could dig into a session trace and see exactly where it took a particularly long time to load a page. I can go in here, and this is going to show us in a view that will be very familiar to front-end browser developers. It's going to show us a view of everything that happened to load on the page and how long each of those different things took to load. So for example, we've got a theme CSS there, and we can see that that took less than a millisecond. We've got some... This is looking at the timing from the browser, yes. So this is how long it took for these resources to load into the browser's page. Yep. So if you've seen the Firefox or the Chrome developer tools, this is very similar to some of the loading details that you would get there. Yep.
One question, there are many kind of personalization or recommendation platforms that basically modify DOM on the fly. Have you been dealing with those? I mean, and the question is that how dramatically they actually impact on the site performance?
That's a great question. I used to work at a company that sold a particular A/B testing tool that worked by modifying the DOM afterwards. There are some extra things you can do to capture that sort of timing data. I'd be happy to sort of go through some of the APIs with you in the next break and sort of talk in more detail about how that works. There are ways to measure it, and they can have an impact on performance. It depends on how fast the rest of your page is. So, yeah. Okay. So you can see here how long individual resources are taking to load. Now, it's worth noting that when you're incidentally, so two things here. This is the actual experience that an actual user has had visiting this page. So where this is unique in comparison to if you were a front-end developer reloading the page in your browser to see how long things took, you would only ever be able to test how long things took for you. Here you can see how long things took for any of your users, which is fantastic and a great way of getting data on lots of different types of browser and operating system and things like that. The challenge when you're collecting this data is that you want to collect as much data as possible without impacting the end user's experience. So what we actually do is we ask the browser for information that it's already capturing in terms of the timing data for all of these resources. And then when the page is finished loading, we send it back to our servers so that you can look at it. And what that gives you is some good general overview of how long some of these resources might take to load. But if I switch across to another site, and I'll show you a few slow loading resources, and then we can talk about how you would actually solve those resources in terms of loading. So here we've got an image there that's taken 3.5 or ish seconds to load. And if we want the whole page to load in less than 3 seconds, we've instantly blown our allowance in terms of time and so on. So what we might want to do there is figure out why that's loading so slowly, whether that's a statistical outlier or not. And to do that, you actually need to leave the browser monitoring to one side, because the browser monitoring includes a huge range of variables that you don't really want to be dealing with, and you want to have a sort of laboratory environment to do a kind of clean room analysis of your user experience. And that's what our synthetics solution allows you to do. So if I switch over to this and go into here. So synthetic monitoring is the activity of sending artificial users at your site. And that can be used to do a number of things: to check your site is open for business, to check the critical path through your site is working, but also to generate data that you can use for further statistical analysis of your performance. So if we dig into one of these results here, you'll see that it's a somewhat similar layout to the layout we had before in terms of the session trace. But what's nice about this is we can actually say, you know what, sort all of the assets by duration. Which of the assets in the page took the longest to load? And because this is an artificial user experience that we've got here, we don't have any constraints in terms of the amount of data we can capture. We can say, you know what, tell us everything about how long these things took to load. So if I click on this serve CSS file, for example, you can see that actually we've got not just how long it took to load, but everything it was doing in terms of loading that particular resource. So you can see that it took a good chunk of time, 9.1 seconds in this instance, just waiting for that resource to be served up by the web server. But still, we want to know if this is a statistical outlier or the normal situation for this resource. So we can hop over to our data workbench and slice and dice this data to find out a little bit more about what's going on. So here you can see all of the resources. I'm actually going to sit down for this because it involves typing, and it always goes wrong when I stand up. And I am going to say, let's see if this is always slow. So let's say from 1 week ago, and I want to say, show me the duration. Okay, so we can see here that actually we've got it looks like the duration is typically sort of in the order of 10 seconds or so, but perhaps I want to say, you know what, I want to see what I don't want to see what averages are, I want to see what the 95th percentile of duration might be, and see whether it genuinely is always slow or not. And you can see here that actually it is pretty much always slow for this resource. So this might be something I would ask my developers to take a look at. Why is this particular page running particularly slowly? Can we dig into this in a little bit more detail and find out what's going on? There's some other neat things we can do as well whilst we're sort of slicing and dicing this data. We might want to say, perhaps it's an issue with the hosting arrangement. So let's say, well, actually let's see what the typical load time is for everything. Pretty slow. And show me by domain, because maybe it's a particular hosting provider that's slow. So here you can see the typical load time for a range of different providers. Let's give it some more graphical representation. And what you can see here quite clearly is that this Andrew Savory guy should not be running a server. But maybe I would want to shift some of my hosting over to Google or the Bootstrap CDN or something like that. And this is a nice way of figuring out not just which resources are slow, but also perhaps what domains you might want to shift your hosting to in order to speed up the experience that you're delivering. Now, all of these queries that I've been doing, I could have actually been adding to a dashboard as I'm going along to build up a track record of information that I can share with my colleagues. Because having data is great, sharing data is even better. Because the more people that are looking at it, the more people can say, see, I know what's going on there, you should be using this, or you should be minifying that, or compressing that image. So throughout all of the process, I could be putting together a dashboard, and it might end up looking something like this, where we're looking at the browser data, some of the most busy pages, we're looking at some of the slow pages and how often they're looked at, we're looking at the slowness of a particular resource, and then we're also digging into, for example, the page load times and figuring out how long these pages are taking to load. All of this, it's just another set of tools that help you to turbocharge your website. So, and I forgot to turn off all of the screenshots. Where's it gone? So remember, 3 seconds. If your site is taking less than 3 seconds, is taking more than 3 seconds to load, bad things will happen. Cart abandonment, unhappy users, a poor customer experience. So think about what tools you can use to help you to understand what that performance is like and how you can optimize it and how you can actually spend the most effective time as developers to improve that performance. That's all I've got for you, so I'll hand it over to questions now.
So let's say 15 years ago, 3 seconds was extremely fast.
Yep.
It was impossible. If the website was loaded in 30 seconds, it was fine.
Mm-hmm.
Now it's 3 seconds.
Yep.
What's it going to be in 2 years? Will it be 1 second, 2 seconds?
I see some sites that load almost instantaneously in the browser. I think that sets a benchmark of performance. If you imagine that networks are only going to get faster, computing devices, whether they're mobile or desktop, will only ever get faster. There's really not much reason why you should be slower than sort of a second or so. If you look at things that you can do in terms of caching as well, single page applications, the initial page load might be a second, but then everything's buffered in the background, lots of AJAX going on. You could get up to the point of having a site that is incredibly performant that users don't even notice that it's loading. There's some research that's in one of those links that actually points to the fact that I think something beyond 0.2 seconds is a noticeable delay for a customer. That's on general computing systems. So I'd like to think we'll get to the point where we can get as fast as that in the future. Might be a few years away.
Okay, yeah. Thanks for the presentation. There is the speed of light is constant, so you won't ever get. There's actually some JavaScript blog post somewhere that's talking about that you won't ever be able to cross a specific boundary. So there's a lower bound of this, but of course with the caching, you might receive then or be able to produce almost instantaneous page loads, as you were saying. My actual question was about these synthetic benchmarks that you have, or the requests that you were making. What kind of, do you have any system for distributing them across geographically?
Yep.
Because I was thinking basically that, I mean, if you have a global CDN setup or something like that in different places, you will end up more or less hitting your neighbor in specific Amazon regions or something like that. So you essentially end up with a completely unrealistic benchmark in that sense. So is this something that you can take into consideration?
So by default, out of the box, we have I think it's about a dozen different locations around the world. You can add your own locations as well if you want to. If you want to run a VM with our software on, you can do that, which is particularly useful if you want to measure internal APIs behind your firewall. So it's also not just a good way of benchmarking your site performance, you can also benchmark your competitors' site performance. You can also benchmark the APIs that your site depends on. So if you have some sort of internal authentication API or something like that, or some other data stream you're using, it's great to have a check that runs on that, because the minute that starts slowing down, you can start proactively resolving that before it really hits your end user's performance. But yeah, good point about if you're running the check from the data center where you're hosting, it's going to look really fast, which is why you have to try checks from lots of different places.
Yeah. Sorry. So just to confirm, did I understand you correctly that you have some software you can download and run these benchmarks with?
Yeah. So we call it private locations, and it's effectively a VM that you stick inside your network, and it will continue to get the instructions from the website, but then it just runs the tests locally, so it can actually talk to internal servers.
And can I run this remotely somewhere?
You could do, yeah. So if you wanted coverage in one of the locations that we don't cover at the moment, and you happen to have a data center there, you could use that. Yeah.
I used to work for a games company, and we had a global CDN, and then we had global availability. So I was curious kind of how well New Relic is these days in terms of troubleshooting kind of very bespoke issues, such as ISPs in China that blocked routing to specific partners, and how well, given, for example, a customer's IP address, I could troubleshoot that to see if it's something wrong with my CDN that's based in China, or if it's a routing issue to my partner, or kind of what's causing the customer's issue. Because we were doing games, and so we had millions of users, and that was generating revenue all the time. But not being in China, it's very hard to troubleshoot my application from a specific IP range or gather data for that particular user. And so does New Relic give any advantages to be able to see for a particular user or a particular subnet what their issue is? Is it me or is it my partners? And kind of getting better data to be able to fix that and kind of get the revenue coming back in.
Yeah. So that's a really tough problem to solve, and we've got this. We're working on this with some of our customers at the moment. They're actually based in China. They have operations there, and it's difficult to get all of the data consistently out of China. It's something that you have to approach on a case-by-case basis. It's worth bearing in mind that this is not necessarily a really low-level network tool. It's a great tool for understanding some of the high-level issues around delivering web page content. But if you want to go for the really low-level stuff, some of the sort of network monitoring specific tools might be better. But I'd be happy to have a chat about the specifics of what you were trying to do and see if there is something we could help with. We have some customers that have deployed private locations in China to sort of to do some monitoring that way, with lesser or greater extent of success. It depends on a case-by-case basis.
Yeah, I mean, I don't work for the games company anymore, but it's just one of the issues that I saw, the kind of geographical troubleshooting. So, for example, if there's a very slow ISP in Texas and they have routing is very slow route to ISPs, it's kind of troubleshooting geographical kind of performance and seeing if the stuff that's broke because of that.
So, the other thing to bear in mind is, synthetics is good for laboratory conditions and can help you diagnose by taking away all of the other possible causes of problems, but it's no substitute for real end user data. So if you've deployed the browser agent as well, you can get an enormous amount of really useful information about applications, and probably the coolest thing is being able to actually filter through that data based on where someone is. So if we look at this, for example, you can see that the website that I'm monitoring here is offering a particularly poor performance in the UK at the moment, for example. And we can dig into this data and find out why it's so poor. So we can zoom into the UK, and you can see that people in London have had a 13.5 second load time, and someone up here in Liverpool had a slow load time. So we can say, all right, we're filtering this data based on the country code. What other ways can we dig into this data to find out why it was slow? So a common reason might be the network that someone was on. You can see here that there are two different networks that these visitors were on, so let's take a look at one of them. So now we're looking at all of the users visiting this site in the UK on this particular network, and we can say, well, maybe it's because they were on a mobile phone, for example. I think this is probably going to be desktop user in this case. But so we can look at all of the desktop users on this particular network in this particular location and get a very, very good idea of how performance actually is in that location. So you could imagine that this would also work really well for seeing how performance was in China or any other location around the world. This particular data set is pretty sparse because it's just people visiting my blog. But when you've got a huge data set, it's amazing some of the things you can find out. For example, you will sometimes see a very, very old Netscape browser type coming from a very specific location in the world, which we know is a certain group of hackers who are trying to cause trouble with different websites. So when you can drill into this data, it offers lots of fascinating stuff.
Any other questions? If it's someone from Hungary with the Amiga 2000, then it's Attila.